practice test review. I'm going to go through these and work them out. Number one, we have this recursive or explicit formula. Wants us first find the first 5 terms. We are going to just plug in 1, 2, 3, 4, and 5 for n to get those terms. So if I plug 1 in for n, I'm going to get 0.5 plus 5.5, which gives me 6. And then I plug 2 in for n, I get 6.5. 3 in for n gives me 7. 4 in for n gives me 7.5. And 5 in for n gives me 8. Since I'm going up by the same amount each time, this is arithmetic. For number 2, we want to find the sum of this series to the nearest whole number. Since we know the first and the last term, and this is an arithmetic series, we're going to say we need n over 2. I don't know what n is yet, times the first term plus the last term, the nth term. Okay, right off the arithmetic series formula on your formula sheet. Now, since we don't know n, this is a little bit complicated. We have to go back to the arithmetic sequence formula, which is this, and find n. Okay, we know the nth term is 424. We know the first term is 6. We're solving for n, and the common difference, what's being added each time, d, is 19. Okay, so at this point you're going to subtract 6, divide by 19, and add 1, and you get n equals 23. So at that point we can plug 23 in for n, and we can simply find this value, 23 divided by 2, times 430, which is what I get when I do 424 plus 6. So we get a value of 4945 as the sum of that series. Number 3, we want the sum of the first 4 terms of this series. All we need for this, since the rate is 8/9 less than 1, the sum of a geometric, which is g sub 1 times 1 minus the rate to the n power, all over 1 minus the rate. The first term is 5. The rate is 8/9. We raise that to the n power. N is the number of terms, so 35th. All over 1 minus 8/9 would be 1/9. Okay, so that's your work for this one. Plugging it in your calculator is a little bit tricky, but if you do it just like I have it written, 5 times 1 minus, parentheses, 8/9, caret to the 35th power, get you that very 4.9, and then if we divide that by 1/9, same thing as multiplying by 9, it gets you 44.3. For number 4, does this series converge or sequence converge? The answer is yes, because the rate is less than 1. So yes, it does converge. This says to find the limit. We're going to find the sum. We didn't do the limit section. So to find the sum of this sequence, we're going to do, remember, the sum of an infinite series is the first term over 1 minus the rate. In this case, the first term would be -6. The rate is going to be 2/3, so 1 minus 2/3 would be 1/3. And -6 divided by 1/3 is -18. Omit number 5. Number 6, the first 4 terms of an arithmetic sequence are right here. Give the explicit formula. Okay, remember, when you're giving a formula, you leave n. So the formula would be a sub n equals the first term, a sub 1, 54.7, plus n minus 1, again, anything with n, you leave it, times d. D is the common difference, and I can find the common difference by doing second term minus the first term. You get -4.1, so you're adding the -4.1 each time. And actually, I'm going to put that -4.1 out front because I'm multiplying. Very hard to see there. So it's 54.7 plus a -4.1 times n minus 1. Recursive formula, you have to list the first term, 54.7, and then you have to say a sub n equals a sub n minus 1 plus the common difference. Well, common difference is -4.1. So that is the recursive formula. That's page 1 of your review.